Hi, everyone. I am here to tell you about the Limudei Code-Esh project. So this is a very exciting project that consists of 6 curricular units that integrate coding, robotics, and computational thinking with holidays, Jewish holidays, and it's designed for children in kindergarten to 3rd grade. So I'm Marina Umas-Chivers. I'm a professor of child study and human development at Tufts University with another appointment in computer science. And I'm the director of the DevTech Research Group. And I've been at Tufts for quite many years. I started in 2001 after I finished my PhD working with Seymour Papert at the MIT Media Lab. And if you hear a strange accent, it's because I'm originally from Argentina, where I did my undergraduate education before coming to the US and going to MIT, and then started my own research group, DevTech, at Tufts University.
And I'm Rachel Weisselman. I am a soon-to-be graduate from Tufts University with a master's in child study and human development. My passion for education and Judaic studies made the Limudei Code-Esh project particularly exciting to be a part of. Marina will talk about that some more.
So let me tell you about this Limudei Code-Esh project that we're here. So it started with a dream, literally a dream. I am Jewish, and I deeply care about Jewish education. I would say that a lot of the best things I learned about education I learned when I was being a madrija back in Argentina. I learned a lot. And a couple of years ago, I was talking with Rose Jane Solomon, who you'll hear more about her. And I was telling her that I've been working for many years with Jewish day schools all over the world, helping them to bring technology into their classrooms. And I did workshops on professional development and individual projects in, the US, Argentina, different states, or lots of them. And I noticed that all of them wanted to tell their story about, Jewish studies and holidays. And sure, coding was interesting, but they needed to integrate because there's so many hours in a day school. And how are you going to bring some new thing? So of course, the natural thing is to bring coding in an integrated way. So I was talking with Rose Jane, and I said, well, you know what? We should create these curriculum units that are already aligned with frameworks, national frameworks, and state frameworks, both in the areas of STEM, but also with some things that we know that we should be teaching about Jewish studies. So any school, formal school or Sunday school or informal learning in the world really could access them and use it and adapt it in their own way. And Rose Jane listened to me, and we had many conversations. And finally she said, you know what? I'm going to honor my husband, who was an engineer. And I think he would have been proud of such a project. And so that's how we embarked in this project that we'll tell you more about it. So we integrate coding, robotics, and computational thinking with Jewish studies. Coding, robotics, computational thinking are all different ways to say that we want children to be computer literate in the 21st century. We want them to learn how to make things with a computer, how to make robots work, and not only become passive users of the technology. And the only way that we can become actives or creators is by making and by programming. And being Jewish also means being an active doer, an active maker. And so really, if you think about it, programming and making robots do things is not so different than the kinds of things and actions and behaviors we take as Jews. So we decided to focus on Jewish holidays, and we chose Sukkot, Chanukkah, Tu B'Shvat, Purim, Pesach, and Yom Ha'atzmaut. Those are holidays that if you're Jewish, regardless of your denomination, regardless of where in the world you are celebrating. So the Judaic material, although both Rachel and I love Judaism and know something about it, we did not develop it. We worked together with a team of Jewish educators representing the Reform, the Conservative, and the Orthodox movements within Judaism, who had meetings to discuss from the very concepts that we were going to teach, to how we were going to teach it, to what kind of Hebrew prayers, to what kind of activities were going to be included. And part of the richness of this program is exactly that it was developed by all of us together. So we have developed 6 free curriculum units. They're designed for a total of 20 hours, but however, they are designed in a way that they are adaptable. So if you are in a Sunday school and you only have 15 minutes at the time, we have activities that are for 15 minutes at the time. And so you can think of it as a modular curriculum where you can put things in place like Lego set that you can arrange and rearrange, but there is a scope and sequence of what you should be doing first and second. It's for K to third, although some people might say, well, I can use this for even pre-K and I can use this for older kids. And sure, of course you can, but we were really focusing on this age range. And finally, none of this would be possible without Rose Jane leadership and her generosity through the David Lear Sullman Computer Science and Engineering Fund for Jewish Day Schools. So let's go to the curriculum. So the first units are based on ScratchJr, and ScratchJr is a free app that my lab developed in collaboration with the MIT Media Lab. And it's very popular. We have over 13 million users all over the world, and it's free, and you can download it to work with Android and iPads and Chromebooks, and I'll tell you a little bit more later about this. But the 3 units that are developed for ScratchJr are Tu B'Shvat, Chanukkah, and Pesach. And the other 3 units are for KIBO, which is a robotic tool that my lab also developed that doesn't require screens. You can program with wooden blocks, and I'll also be telling you about that. And the holidays are Sukkot, Yom Ha'atzmaut, and Purim. And so if you look at these holidays together, the 6 of them, they are designed in such a way that you can weave in and out of screen-based and robotic-based activities. So first and foremost, this is a team project. So I'm just leading it, but all the wonderful students from my DevTech Research Group, we have a lot of grad students and undergrad students working over 2 years on this project. And Rachel was very, very deeply involved, so that's why she's here, but there's a lot of other people who were very involved in all of the activities. And the teachers who contributed great deal to this were Michal Bessler from the Maimonides School in Brookline, Massachusetts, Dan Savit from Solomon Schechter Day School in Greater Boston, and Fallon Rubin from Temple Israel of Boston informal education setting. So we have representatives from both day schools and informal and different denominations. And projects advisor were Rina Slovin and Rabbi David Salzman, who were wonderful at helping us put things in context and understand how to really integrate Jewish studies into our coding curriculum. And of course, our project hero is Rose Jane Solman, who wasn't just a funder. She became thoroughly involved in the project, carefully editing, carefully reading, participating, cheering all the way, critiquing what it needed to be criticized. So none of this could happen without Rose Jane.
Thank you, Rose Jane.
ScratchJr Platform. The 3 curriculum units are organized in terms of beginner, intermediate, and advanced. So that means if you want to start with a kindergarten beginner classroom, you can start with Tu B'Shvat. But maybe your kids have already had ScratchJr when they were in pre-K, and you have a kindergarten classroom that is at the intermediate level because they already know ScratchJr. So you can start with Chanukkah. So these are not, what I'm trying to say is these are not age level, they are computing skills level. And they are designed in a sequence. Tu B'Shvat, Chanukkah, and Pesach is the advanced unit. So before we go forward, let me tell you about what ScratchJr is. So as I mentioned before, it's a free app, and you can create your own background. You can paint, you can choose from already existing backgrounds, or you can take pictures of things that you like. So I'm gonna choose a plant, and I'm gonna then create characters that live with this plant. I can choose from my gallery, I choose a frog. And now I'm gonna program my frog to start on the green flag, to hop twice, to grow twice, to shrink twice. I'm gonna record the sound. I'm gonna place my sound bit there. I'm gonna repeat this action 4 times. And now I'm gonna end my sequence. And if you see the frog right now, it's jumping and repeating this sequence of commands 4 times. I can go ahead and create new pages for my story. I can use a grid for math, and of course include text if I'm just learning how to use letters. So that's the beginning of ScratchJr. What you saw there was a sequence, and in fancy terms, that's an algorithm. But algorithms and sequencing, which are at the concept of programming and building computational skills, are really fundamental for anything else that we do in early childhood. They are foundation for math, for literacy, for executive function, anything you want. So ScratchJr can be free downloadable here, this website, and I invite you all to do and explore. So let's dive into our curriculum units. Limudei Code-Esh Tu Bishvat, that's a beginner curriculum unit. And what you see here in blue are the powerful ideas or powerful concepts and skills that are associated with computer science. And what you see in green are those associated with the Jewish studies. So in terms of the blue, we deal with such ideas as the design process, where children learn to come up with their own ideas, refine those ideas, create prototypes, test those prototypes, redesign the prototypes, and then share with the community, and then get new questions. And it's an iterative design process. We, of course, talk about sequencing and algorithms, which is at the basic of creating a set of instructions for someone else, in this case, the ScratchJr cat or anyone else to follow. Concept of representation is very important. You saw that in this programming language, we don't use words to program, we use icons. Icons represent commands and actions, symbol systems. Early childhood is all about learning how to manipulate symbol systems. And debugging, which is a huge concept. The idea that I learn by fixing, that I learn by going over the work I did and see what doesn't work and finding strategies for problem solving. Computational thinking, coding, programming, robotics, it's all about problem solving, same as life.
The Judaic powerful ideas, similarly to that of the computer science powerful ideas, permeate throughout each curriculum. The Tu B'Shvat powerful ideas include cycles of the year, representations of and appreciation for trees, rituals of Tu B'Shvat and the 7 species, recycling and the environment preservation, and Tikkun Olam. These are some of the activities you will see in the Tu B'Shvat curriculum. What is a program serves as an introductory lesson to the coding concepts present in this curriculum. Students are introduced to both the motion blocks and the importance of trees in this holiday during the programming activity where children program an apple to fall from a tree. In programming a recipe, students discuss recipes that incorporate the 7 species of foods present during the holiday of Tu B'Shvat. They then program ScratchJr to follow the steps of the recipe. The Tikkun Olam activity asks students to think about healing the world and create a ScratchJr program to show someone helping someone else.
The second ScratchJr curriculum, which is an intermediate curriculum, but remember, you can start it, doesn't matter the age of the children, it's really the skills that they have developed. So you will see in terms of computer science and computational thinking and robotics, there are some of the same ideas, algorithms, sequencing, debugging, design process, representation, but we're introducing new ones. We're introducing the concept of control structures and modularity. Control structures is a, fancy word for repeating something, for if something happens, then I'll do something else. And modularity is a fancy term for understanding that you can put together complex sequences into something else and then reuse that something else. So you can break up complex problems into small parts. So all of these powerful ideas of computer science are revisited, but in more depth. And actually, by the way, these are the same powerful ideas that we study in undergrad as well as in grad school. It's just that the level keeps every time being more advanced. For example, artificial intelligence is a form of algorithms. And so we're not shortchanging little children. We're teaching them at a basic level, at a foundational level, the precursors of what they will need to grow into understanding even more complex concepts in computer science.
In the Hanukkah curriculum, students are exposed to the powerful ideas of preserving Jewish identity, the battle against the Greeks, miracles, the Chanukkah, Festival of Lights, traditions, and the Maccabees. They participate in the following activities: the programming of ScratchJr to tell the story of the miracle of the oil, the use of ScratchJr to show the appropriate settings to use the menorah compared to the Chanukkah, the proper sequencing of lighting the Chanukkah, which incorporates recording the blessings and properly lighting the candles, and a celebratory activity to recall the traditions of Hanukkah, where they program ScratchJr to sing and dance to everyone's favorite Hanukkah song, O Hanukkah.
Finally, our advanced ScratchJr curriculum brings it all together. So it's a way to really go in depth into the powerful ideas of computer science on the topic of Pesach.
So the powerful ideas for Pesach are chametz and matzah, the number 4 in the Haggadah, retelling the story of Pesach, freedom versus slavery, and the 4 children in us permeate the Pesach curriculum. Students use ScratchJr to program a recipe for making matzah, create a ScratchJr quiz game to review their knowledge of Pesach, collaborate with peers to make a multi-tablet project that represents the proper sequencing of the Seder, and retell the story of Pesach using the programming knowledge they've learned so far.
So if you want to learn more about ScratchJr, we invite you to visit all of these resources that we have available. We also have a book, the official ScratchJr book, and a set of coding cards, which are games for professional development for teachers. But if you go to our website or the scratchjr.org, you can find tutorials videos, you can find activities, you can have unplugged games to introduce ideas of sequencing and algorithms and modularity and control structures. And you can also find assessments and way to assess if children are actually learning. Of course, they're going to be having fun, but are they really learning about this? So our last set of curriculum units was designed with the KIBO platform to give children the opportunity of having a hands-on experience. ScratchJr is wonderful, but it's on the screen. And that's why when we're thinking about computational thinking and computer science, you know, all of our interactions with technology are not just through the screen. Robotics are important in technology society, and robotics might look like robots, but might also be something as simple as having a sensor. So if you go, for example, into the airport and you want to wash your hands and you put your hands out, the water is going to come out from the faucet, and that's because there is a sensor, sensor that detected that something was covering it. So that is, some might say, well, that is a robot, right? Someone programmed this sensor to behave in a certain way. So it's very important to bring the ideas of hardware and software together with the idea of computer science. That's why we have both ScratchJr, which is on the screen, and KIBO, which is a robotic platform. So we have a beginner Sukkot, intermediate Yom Ha'atzmaut, and an advanced Purim curriculum. Let me tell you about KIBO. This is how KIBO works. You don't need a screen. You have a little cute orange robot that has sensors on top. You have an ear, that's a sound sensor. You have a telescope, that is a distance sensor that detects if something is far or near. You have an eye, light, that detects if there is light, and then in the back you cannot see, it's a light bulb that lights up in different colors. And you have all kinds of extensions and platforms that you can put on top of KIBO to decorate it. And you have a microphone, you can record your voices. And those wooden blocks that you see there on the left, that's your programming language. It's very similar to the concept that we use in ScratchJr. They're icons that represent the actions for the robot. And the robot has a scanner. You see, some kids call it the mouth of the robot. It's not a mouth, it's a scanner. And if you look in detail, the blocks have barcodes. So just like in the supermarket, that I know how much everything costs because there's a scanner that scans the barcode of my food, similar is here with KIBO. And so I want to let the expert, who's a 5-year-old, explain to you how you program with KIBO.
Begin, beep, go forward, then we're going to be like, to the right, no, to the left, right, left, right, left, right, left.
So he's scanning all the blocks, this very long sequence of commands that tells KIBO what to do. That's also an algorithm. And now the program is saved. And you can see the robot following the actions that they were programming to. So of course, once you get very comfortable and an expert coder, you can do it on the floor. You don't need to be sitting down or standing up, and you can do it even with one hand. And as you can see here, this child has programmed a very, very long algorithm, and I think he'll have a lot of debugging to do from what I can see here. And that's where the fun of programming starts, where you start finding problems and solving them and fixing them. So the KIBO beginner curriculum is focused on Sukkot, and some of the same powerful ideas of computer science that we explore in ScratchJr curriculum, but this time are explored with a robotics system. So representations of the wooden blocks that correspond to actions, that correspond to words on the block. So my block has a code, a barcode, has a symbol, and has words that I can use. All of those are different forms of representation. This is wonderful for schools that want to emphasize that it could be in English, it could be in Hebrew, it could be in Spanish, it could be in any, just what is the concept of language and how language serves us to represent a given, the importance of Hebrew in Jewish day schools. The concept of representation is very, very powerful. Not just in computer science, but it can apply. And of course, debugging, design process, and algorithms that we explored before.
The Sukkot curriculum's powerful ideas include nature, the sukkah, the 4 species of plant, impermanence versus permanence, gratitude and forgiveness, mitzvot, and rejoicing. In the curriculum, you will find the following activities, just to name a few. In the sukkah scavenger hunt, students create schach using classroom materials and scatter them around the room. They then go on a scavenger hunt where they program KIBO to make stops along the way around the classroom to find the schach supplies. In the building a sukkah, students use Legos to build a sukkah that can be placed on KIBO. One of the great things about KIBO is that it does have extra parts that can go on top of it to allow for a Lego activity where you attach the Legos. In the building a sukkah, students use Legos to build a sukkah that can be placed on KIBO. They then program KIBO to move around and wander like the Jewish people once did. The Shake It Up activity represents the importance of the shaking of the lulav and etrog. You can see this in a couple of these pictures. Students attach a lulav and etrog to KIBO and program KIBO to move in all 4 directions and shake as one does with their hands while holding these objects.
Our intermediate curriculum is Yom Ha'atzmaut, where we're celebrating Israel, and powerful ideas are, again, debugging, representation, algorithms, modularity, and we're introducing control structures in the form of repeat. Repeat 4 times, go forward twice. That means multiplication, right? 4 times 2, it's 8. So control structures and repeats are a form of learning about multiplication without even mentioning the word multiplication, and modularity again.
The powerful ideas of Yom Ha'atzmaut curriculum are Israel, state, celebration, independence, key figures, and symbols, which of course brings in that topic of representation again. In what is Yom Ha'atzmaut, students practice sequencing by programming KIBO to move to and stop when it reaches the 5th of ER on a previously made calendar. The Israeli flag activity incorporates the drawing tool that's also an extension from what Marina had discussed before, and they attach that to KIBO, and students program KIBO to move in a way that it draws the Israeli flag. The Hatikva recording activity makes use of the recording pieces associated with KIBO and allows for students to practice reciting the Hatikva. Lastly, the KIBO parade is a celebration of Yom Ha'atzmaut and a recognition of the traditions used today to celebrate this holiday.
And finally, an advanced KIBO curriculum, it's on Purim. And again, the same powerful ideas of computer science. We take many, many years. I revisited them doing my PhD. It's just that the level in which they are explored is a lot of depth. We are adding a new one, which is hardware and software, because we want to really get children to understand the system of a computer system, which is not just what happens in the screen, is the connection between hardware and software. What I program has a physical representation in the outer world.
The Purim powerful ideas include perseverance, hidden miracles, mitzvot, minhagim of Purim, and the power of community. The following activity sneak peek is comprised of students putting on a play with KIBO to explain the story of Purim, students programming KIBO to collect scattered pages of the story of Esther in the proper order, students creating a Hamantashen game and programming KIBO to play it at a carnival, and students programming their KIBOs to participate in a class Purim parade.
So you can see here some of the characters that were performing in a parade here. You guess who's who. So if you want to learn more about KIBO, again, our DevTech website at Tufts has a lot of free resources, and Kinderlab Robotics, which is the company that commercializes KIBO, it also has a lot of resources available. So I hope you had enjoyed this webinar. The idea was to give you an introduction to the Limudei Code-Esh project. If you have any other questions, you want to learn more, you need help, you want resources, please email me. We invite you to visit that link for the Limudei Code-Esh project. And of course, again, our deep appreciation for the David Lear Sulman Computing Science and Engineering Fund for Jewish Day Schools. Thank you.
Thank you.